What if the most important discovery in human history is happening right now, and most people have no idea it is even being discussed? You have been following 3I Atlas. You know the numbers, you know the trajectory, you know the jets and the water and the organic molecules streaming off its surface as it cuts through our solar system. But here's the question that a small group of Harvard-level scientists are now asking in peer-reviewed papers. Not on forums, not on podcasts, in actual published research. What if 3I Atlas is not just carrying the building blocks of life? What if it is carrying life itself? And what if a brand new study published in March 2026 just proved that the one thing standing between that question and a real answer, the one scientific barrier everyone assumed made it impossible, has just been knocked down? Because that is exactly what happened. By the end of this video, you are going to understand why this changes everything. Not just about 3I Atlas, but about where life on this planet actually came from. Subscribe to Space Aquarius and let's begin. Let's back up for just a second because you need one piece of context to make everything else land properly. There is a theory in science called panspermia. It has been around for a long time. The basic idea is simple. Life does not necessarily start fresh on every planet. Instead, life, or at least the raw ingredients for life, can travel through space on rocks, comets, and other objects, and seed new worlds when those objects land somewhere with the right conditions. It sounds like science fiction, but the science behind it is real, and it has been getting stronger every single year. The reason most scientists have kept panspermia at arm's length is not because the idea is crazy. It is because of one very specific problem. Survival. Getting a microbe from one planet to another requires surviving 3 brutal stages. First, the initial blast, when an asteroid or comet slams into a planet and ejects surface material into space at enormous speed. Second, the long journey through space, years, decades, sometimes millions of years of freezing temperatures, radiation, and zero nutrients. Third, the landing, slamming into a new planet's atmosphere at high velocity. Most scientists assumed stage 1 alone was enough to kill everything. The pressures involved in an impact ejection are almost incomprehensible. We are talking about forces that would crush steel. That assumption just got seriously challenged. A study published in March 2026 in the journal Astrobiology took a specific microorganism called Deinococcus radiodurans and subjected it to controlled high-pressure impacts in a laboratory setting. Now, if you have not heard of Deinococcus radiodurans, here is what you need to know about it. Scientists call it the world's most radiation-resistant organism. It has been listed in the Guinness World Records. It can survive doses of radiation that would kill a human being thousands of times over. It can survive complete dehydration. It can survive the vacuum of space. It can repair its own DNA after damage that would destroy virtually any other living thing on Earth. It is, in the most literal sense, nearly indestructible. But nobody had tested whether it could survive the kind of pressure generated when a meteor slams into a planet and blasts surface material into orbit. The researchers fired samples of Deinococcus radiodurans at high-velocity targets, generating pressures of up to 20,000 times the atmospheric pressure we experience here on Earth at sea level. That is the kind of force generated during a real planetary impact ejection event. And the results stopped people cold. Deinococcus radiodurans survived. Not all of it, not at the highest pressures, but at pressures up to roughly 290,000 pounds per square inch, the kind of force that occurs during actual impact events on Mars. A meaningful portion of the bacteria came through intact. Their cell walls were undamaged. Their internal structures looked normal under an electron microscope. They were alive. Stage 1 of the panspermia survival problem just got crossed off the list. Now here is where 3I Atlas walks back into the room. Avi Loeb has been writing about this connection directly. In a paper published in early 2026, he laid out a scenario that is worth walking through carefully because it is not as far-fetched as it might sound on first hearing. Here's the core of what he proposed. Mars and Earth have been exchanging rocks for billions of years. When large asteroids hit Mars early in the solar system's history, the impact blasted chunks of Martian surface material into space. Some of those chunks eventually drifted close enough to Earth to get pulled in by gravity and land here. Scientists know this is real. We have actually found Martian rocks on Earth. One of the most famous is called ALH 84001, a meteorite discovered in Antarctica that originated on Mars. What the research showed about ALH 84001 is remarkable. Scientists analyzed the thermal history of that rock during its journey from Mars to Earth. It was never heated above 104 degrees Fahrenheit during the entire trip. That is cooler than a hot summer day in Phoenix, Arizona. Meaning, if there were microbes inside that rock when it left Mars, they could have survived the journey completely intact. Now here's the part that connects to the new impact study. The last universal common ancestor of all life on Earth, scientists call it Luca, has been dated to approximately 4.2 billion years ago. That is just a few hundred million years after Earth itself formed. Life appeared on this planet almost immediately in geological terms. But Mars is a smaller planet than Earth. Smaller planets cool down faster after formation because they have more surface area relative to their volume. Mars would have reached stable, habitable surface conditions before Earth did. Put those two facts together. Mars had liquid water and stable surface conditions before Earth. Life on Earth appeared almost immediately after Earth became habitable. And we know rocks traveled from Mars to Earth during that exact time window, and we know those rocks stayed cool enough to preserve living organisms during the journey. Loeb's conclusion, shared by a growing number of astrobiologists, we might all be Martians. The first life on Earth may have arrived on a Martian rock, and the microbe that started everything, the ancestor of every living thing on this planet, including you, may have originated on a world that is now a frozen desert 140 million miles away. But here's the part that brings 3I Atlas directly into the picture, and this is where the story takes a turn that most people have not fully processed yet. If microbes can survive the violent ejection from a planet's surface, which the March 2026 study now confirms, and if they can survive the cold, radiation, and vacuum of space during a long journey, which earlier research on Deinococcus radiodurans already demonstrated, then the question is no longer can life travel between planets. The question becomes how far can it travel? And the answer to that question depends entirely on what is doing the carrying. A rock ejected from Mars travels at relatively modest speeds. It might take thousands or millions of years to drift to another planet. The distances involved within our solar system are manageable, but 3I Atlas is traveling at over 130,000 miles per hour. It came from another star system entirely. It has been traveling through the galaxy for what researchers now estimate is somewhere between 10 and 12 billion years, more than twice the age of our solar system. And NASA's Sphere-X Space Telescope detected organic molecules coming directly off 3I Atlas as it made its closest approach to the Sun. The molecules detected included methanol, cyanide, and methane. Compounds that are, as NASA's own statement put it, fundamental to biological processes on Earth. The building blocks of life, streaming off an interstellar visitor in our solar system, right now. Loeb took this one step further in his published writing, and it is worth quoting the spirit of what he said directly. He pointed out that if our civilization wanted to spread life to other star systems, we now have a roadmap for how to do it. You package microbes with nutrients and a small power source. You attach that package to an interstellar object like 3I Atlas. The object carries your package across the galaxy for free. When it enters the habitable zone of another star system, the package deploys, and life gets a foothold somewhere new. He called it directed panspermia, the deliberate technological seeding of life across the Milky Way. And then he asked the question that sits at the center of all of this. If we can imagine doing that, if we, in 2025, with our current technology and our current space budgets, could have launched a payload onto 3I Atlas when it was first detected in July 2025, then what is the probability that a civilization billions of years older than ours has not already done exactly that? The organic molecules coming off 3I Atlas are consistent with what you would expect from a natural comet. Nobody is claiming otherwise. But they are also consistent with what you would expect if something had been living inside that object for a very long time. We cannot tell the difference yet. Here's where the science stands right now. Microbes can survive 290,000 pounds per square inch of impact pressure. Confirmed March 2026. Microbes can survive the radiation and cold of space travel. Confirmed by years of prior research. Life on Earth may have arrived from Mars on a rock that never got warmer than 104 degrees Fahrenheit during transit. 3I Atlas is releasing the building blocks of life as it moves through our solar system. And it has been traveling through the galaxy for up to 12 billion years. Every one of those facts is documented, published, peer-reviewed. What nobody can tell you is whether any of those facts are connected. Maybe 3I Atlas is a spectacular natural comet, and the organic molecules are exactly what they appear to be. Chemistry, not biology. Maybe panspermia is real but purely accidental with no intelligence behind it. Or maybe the most ancient object ever detected passing through our solar system has been carrying something across the galaxy for longer than our sun has existed. And maybe the new study proving that life can survive the violence of planetary ejection is not just an interesting data point. Maybe it is the missing piece that makes everything else make sense. The Spherex findings are still being analyzed. The James Webb Space Telescope data is still coming in. And the full picture of what 3I Atlas is carrying, chemically, biologically, or otherwise, has not been written yet. If this video got you thinking, subscribe to Space Aquarius. Drop a comment below and tell me where you stand. Purely natural chemistry, accidental panspermia, or something deliberate? Every comment gets read, and if this video made you stop and think, share it with someone who would want to know about it. The conversation is just getting started.